Here we have a system of equations that we're asked to solve, and then there's three different answers we could possibly get. Either we'll get an XYZ, or we'll get possibly infinitely many solutions, and this one's going to take a little bit more to solve because it wants a parameter of n, or we could get a no solution. So here's our system of equations, and let's go ahead and look at how we're going to solve this system of equations. So, as you can see, I've written our system on a piece of paper, and I'm going to rewrite this in an augmented matrix so we can solve. So my augmented matrix is going to be my coefficients. 1, 2, 3, 1, and then 3, 2, 1, 2, 3, 2, 1, 2, and then 11, 10, 9, 8. 11, 10, 9, 8. So again, all my x's are lined up, all my y's, z's, 1, 2, 8, and you can see I've put them in my augmented matrix. Okay. Now we can solve this, and we're going to do this by using our calculator. So here I have my TI-83, and I'm going to put my matrix in. So as you can see above here is matrix, so I'm going to second where I have my matrix. We're going to scroll over to edit, and I'm going to put it in matrix A, so I'm going to hit enter since it's highlighted. And this is a 3 by 4 row by column, so it is a 3 by 4 matrix. 3 by 4, enter. And now I put my coefficients in. 1, 2, 3, 1. And it's important to make sure you get your matrix correct. Otherwise, we won't get the correct answer if we don't put in the correct numbers. So I always like to double check even after I get them in, just to make sure I have the matrix correct before I do our reduced row echelon. Alright, so let me double check. So this is the last row, 8, 9, 10, 11. Okay, this should be 3, 2, 1, 2, 1, 3, 2, 1. So it looks good, and I need to get out of this area of my calculator. Second, quit. So that gets us out of there. We're going to go back to where our matrices are. And you can see now I have a 3 by 4. So there's my matrix. I'm going to scroll over 1 to math. And I'm going to arrow up or down. It really doesn't matter which way until I see RREF. And that's reduced row echelon form. So this is going to do that Gauss-Jordan elimination for us. It's going to give us our reduced row echelon form matrix. So that's what I want to do. So click enter, go back to matrix. This time I'm going to leave it right there because that's the matrix I want. Enter, and you can see matrix A. I close my parenthesis and then enter, and it gives us an answer. So I'm going to write this down here, what we got, and then we're going to see if we can interpret this reduced row echelon matrix. 0.5, 0.25, 0, 1, 2, and then 0, 0, 0, 0. And then we can convert these to fractions if we want to, and we can do that on our calculator also. If you go to math, and this is going to convert a decimal to a fraction if it's possible, enter, and you can see it will do that for us. So either way, we can come up with fractions or we can use our decimals. So this is what we really need to look at as far as, well, what's our answer going to be? So I'm going to move my calculator out of the way for right now, and let's see what we have. Now, remember, these were my x's, these were my y's, these are my z's, and these are my constants. This last row is what I'm looking at right here. So this right here, 0 equals 0. And that's true. That is true. So that's telling me I have an infinitely many solutions. So infinitely many solutions. But I'm not going to leave that as my answer, because in the question it asked us to express it in terms of x, y, z, or express x, y, and z in terms of a parameter n. So we were told our parameter, if this is the case, which it is going to be n. So everything's going to be as far as n in terms of n. So again, we have an x, y, and z. So n can be anything. So n can be anything. This is my z, n, z. So I need to find my x and y. Because remember, it's not just an x and a y, we have an x, y, z. So our answer should be x, y, and a z. Okay, so I need to find out what's right, my first term in terms of n, and then the second term, which is the y, going to be in terms of n. So I'm going to go up here and look at this row and rewrite it as an equation and see what I have here. So that's going to be 1y plus 2z equals 0.25 or 1/4. I'm going to write it as a fraction. And then I'm going to go back up here and rewrite this first row, which is 1x plus 0y, 0, minus 1z equals 1/2. Now I just need to solve this for y. Okay, solve this for y. And we said z, right, we know z is n. Okay. So let's see here. I have y equals negative 2z plus 1/4. So since it said write it in terms of n, well, we said z is n, so I'm going to change that to an n. To n plus 1/4. So this answer is going to be negative 2n plus 1/4. I'm going to do the same thing with my x equation that we got from an augmented matrix. So let me move my paper up here just a little bit. So x, well, that's 0 minus z equals 1/2. So it's going to be x equals z plus 1/2. Remember what z was, that's n. So x equals n plus 1/2. So in my x position here, I'm going to put n plus 1/2. So my final answer in terms of n is n plus 1/2, negative 2n plus 1/4, and n. So I can pick any n, whatever it may be, and substitute it into my x and y's and get an x, y, and z.